Hello guys, welcome back to our YouTube channel. Guys, today in this video, we are going to discuss about the term NPSH. Guys, you might remember that few videos ahead, we discussed about NPSH, NPSH available and NPSH required. So guys, particularly in this video, we are going to discuss how can we calculate NPSH or how is NPSH calculated. And we will understand it with the help of an example. Okay guys, so now let's get started with NPSH. Guys, before we start with the calculation part of NPSH, let's firstly recall what is NPSH. So guys, NPSH stands for net positive suction head. It is a crucial component in the operation of pumps and especially talking about the centrifugal pumps. Guys, it relates to the pressure conditions which are required to avoid the cavitation. Okay, now talking about NPSH available in brief. Guys, NPSH available is the net positive suction head available and it represents the actual pressure at the pump suction pot. It is the measure of the absolute pressure in the liquid just before it enters the pump and adjusted for vapor pressure. Guys, it is calculated using the formula of NPSH available is equals to P atmosphere upon rho g plus P static upon rho g minus P vaporized upon rho g plus V square by 2g minus HF, where HF is head loss due to friction in the suction line. Okay, and on the other hand, talking about NPSH required, guys, NPSH required stands for net positive suction head required. It is a minimum pressure head which is needed at the pump suction pot to prevent the cavitation within the pump. Okay? Guys, NPSH required is a characteristic of the pump itself and it is provided by the pump manufacturer. It normally depends on the pump design, operating speed and the type of the liquid which is being pumped. Okay guys? It is necessary to ensure that NPSH required, that is, the liquid remains above its vapor pressure and avoids formation of vapor bubbles that collapse and cause cavitation. Okay guys, so this was a brief about what is NPSH, what is NPSH required, what is NPSH available. Now moving on, in this video, we are going to discuss about how is NPSH calculated. So to understand the calculation of NPSH more easily, we will understand it with the help of an example. Okay guys, so here is a scenario where the pump is located 5 meters above the reservoir. The atmospheric pressure is 101.3 kilopascal. The water which is to be pumped is at a temperature 20 degrees Celsius with a vapor pressure of 2.34 kilopascal. And at the suction side, the suction pipe has a diameter of 0.15 meter and a length of 10 meters. Also, the friction losses in the suction line is 0.5 meter, which is given here. In some cases it is not given and you need to calculate the friction losses with another formula. Okay guys, moving ahead, the pump flow rate is also given here, which is resulted in a velocity head form and which is given as 0.2 meters. Guys, the same calculation part goes here also, where if velocity head is not given, you need to calculate it by the help of formula of V square by 2g. Okay guys, but here in this situation it is given. The next example, we will consider calculation of V square by 2g, which is velocity head, and after calculation of it, we will move ahead towards the NPSH available calculation. Okay guys. Also, in this particular question or in this particular problem statement, the density of water is also given as 1000 kg per meter cube. And guys, the pump manufacturers NPSH required for the given operating condition is 3 meter. Okay. Now guys, to calculate NPSH available step by step, let's break the equation of NPSH available, which is NPSH available is equals to atmospheric pressure upon rho g plus static head upon g minus vapor pressure of the liquid at the pumping temperature upon rho g plus V square by 2g, which is the velocity of liquid in the suction line, upon 2 into g, which is acceleration due to gravity, minus HF, which is head loss due to friction in the suction line. Using this formula, we will calculate the NPSH available by breaking this equation into step by step and calculating each and every individual term. So guys, let's start with the calculation of NPSH available by calculating the first term, which is convert the atmospheric pressure to head. Okay guys, so here the first term of our NPSH available equation is atmospheric pressure upon rho g. So which will be calculated as 101.3 into 10 raised to 3, which will come into Pascal upon density is given as 1000 kg per meters cube into acceleration due to gravity is given as 9.81 meter per second square. And on calculating it, the first term, which is atmospheric pressure upon rho g, will come as 10.33 meter. Okay guys, so please remember this 10.33 meter, which is the value of the first term. At last, after calculating each and every individual terms, we will combine all the terms into the equation and get the NPSH available. Now guys, talking about the second term, which is static head. Guys, static head is the height of liquid above the pump suction. Okay, and the pump suction is here located at 5 meter above the reservoir. So the static head here is 5 meters, which will be negative because the pump is above the reservoir. And in some another different scenario where the pump is below the reservoir, the term we will consider the static head in positive. Okay, so guys, the second term, which is at static, will be minus 5 meter. Okay guys, now moving on with the third term, which is vapor pressure upon rho g. Guys, here the vapor pressure was given as 2.34 kilopascal. So for better calculation, we need to convert the kilopascal into pascal by multiplying it into 1000. So here the vapor pressure will be 2.34 into 10 raised to 3 pascals and dividing it by the density into gravity, acceleration due to gravity, which is 1000 into 9.81. And this way the results come to be 0.24 meter. So guys, we will get the head as 0.24 meter. So the value of third term we will get as 0.24 meters. Okay guys. Now moving on with the fourth term, which is velocity head. Calculating velocity head, the equation will be v square by 2g. But in this particular problem, the velocity head is directly given to us. So we will take the velocity head directly, which is 0.2 meter. In the next problem, we are going to calculate the velocity head also. Okay guys. So for this question, now we will calculate the fifth term, which is friction loss in the suction line, and which is also directly given in the particular scenario and which is given as 0.5 meter. So guys, here we get all the values of the particular terms, and keeping all the values in the equation of NPSH available, we will get NPSH available as 4.79 meters. Okay guys. Now comparing the NPSH available and NPSH required, guys, NPSH available on calculating we got as 4.79 meter, and on the other hand NPSH required was given as 3 meter. And guys, since the NPSH available, which is 4.79 meter, is greater than NPSH required, which is 3 meter, the pump will operate without cavitation. Okay guys. On the other hand, if it might happen that NPSH available is less than NPSH required, then there are chances of cavitation, and we need to do the particular changes to avoid the cavitations. Guys, particular in this example, the pump will function properly without the risk of cavitation because the NPSH available exceeds the NPSH required, and this ensures that the pressure at the pump inlet remains sufficiently above the liquid vapor pressure, which is to prevent vapor bubble formation. Okay guys. Now guys, moving on towards the second scenario, where we are also including the calculation of velocity head in detail. Okay, so guys, in this scenario, the pump is located 3 meter above a water reservoir. Then the atmospheric pressure, which is PATM, is 100 kilopascal. Along with this, also it is given that the water temperature is 25 degrees Celsius with a vapor pressure of 3.17 kilopascal, when the suction pipe inlet diameter is 0.1 meter and the length of the pipe is 8 meters. Then guys, it is also given that the flow rate of the liquid which is flowing in the pipe, which is flowing in the suction pipe, is 0.01 meter cube per second. Along with it, it is also given guys that the friction loss in the suction line is 0.6 meter. Okay, and it is given that the pump manufacturer's NPSH required for given operating condition is 2.5 meters. Okay, now after reviewing all this given data, we are moving towards the step-by-step calculation of NPSH available. So guys, firstly starting with conversion of atmospheric pressure to head. Here in this equation of atmospheric pressure upon rho g, the atmospheric pressure was given as 100 kilopascal, and for better calculation point of view, we are converting it into pascal. So it will be 100 into 10 raised to 3 pascal. And the equation here is atmospheric pressure upon rho g, which will be 100 into 10 raised to 3 upon 1000 into 9.81. And on calculating it, we will get atmospheric pressure upon rho g as 10.19 meters. So here the atmospheric pressure is now converted into head, which is 10.19 meter. Okay, now talking about the second term, which is static head. Guys, you all know that static head is the height of liquid above the pump suction. Here, since the pump is located 3 meter above the reservoir, the static head will be -3. So here it is written as H static is equals to -3 meter, and which is because the pump is above the reservoir. On the other hand, in other cases, if the pump is below the reservoir, then we would consider it positive. Okay, so the second term, which is directly given as -3 meters. Now talking about the third term, which is converting the vapor pressure to head. Here the equation will be vapor pressure upon rho g. Guys, the vapor pressure was also given in kilopascal, which was 3.17 kilopascal. Converting it into the pascal, we will get 3.17 into 10 raised to 3 pascal. And dividing it by the density and acceleration due to gravity, we would get it as 0.32 meter. Here we did the vapor pressure, which is 3.17 into 10 raised to 3 upon 1000, which is density, and to acceleration due to gravity, which is 9.81. Ultimately, on calculating it, we would get the vapor pressure head to be 0.32 meters. Okay guys, so the value of third term is 0.32 meters. Now for calculating the fourth term, which is calculating the velocity head. Guys, the equation of velocity head is v square by 2g. And guys, here in this scenario, we don't have velocity. So first of all, we need to calculate the velocity to fulfill the term of v square by 2g. Okay guys, and to calculate the velocity, we need to firstly have the area or the cross-sectional area of the pipe. So first of all, we will start with the calculation of cross-sectional area of the pipe, moving on towards the velocity of the pipe, and after getting the velocity of the pipe, we will calculate the velocity head. Okay, so first of all, start with the cross-sectional area of the pipe. Here in this scenario guys, it was given that the diameter of the pipe is 0.1 meter. So the area of the pipe, which we all know that it is pi r square. Here it is taken as area is equals to pi d by 2 square. So on calculating it, we get the area as 0.00785 meters square. After getting the area, we need to put it into the equation, which is V is equals to Q by A, where we have find the value of A, and Q, which is the flow rate, is already given in the scenario, which is the flow flowing through the pipe, which was given as 0.01 meter cube per second, and area was calculated as 0.00785 meters square. And on dividing both the terms, we get velocity as 1.27 meter per second. Okay guys, so the purpose is now solved. After we get the velocity, we are putting it into the equation to calculate velocity head, which is v square by 2g, and placing the velocity, which is 1.27, into the v square by 2g equation, which is 1.27 square upon 2 into 9.81, we get the velocity head as 0.08 meter. And guys, at last, the fifth term which is required for NPSH available calculation is friction loss in suction line, which is also directly given in this scenario and which was given as 0.6 meter. Okay guys, so now it is clear that all the 5 terms are obtained in form of heads, and putting all the 5 terms in the equation of NPSH available, we will get the NPSH available as 6.35 meter. Okay guys, now it's the time of comparison. Guys, you all know that the NPSH required was given to us as 2.5 meter, and after calculation of NPSH available, we got it as 6.35 meter. Since NPSH available is greater than NPSH required, the pump will operate without cavitation, right? So guys, in this example, the net positive suction head available, which was 6.35, which is well above the net positive suction head required of 2.5 meters, and this indicates the pump will function properly without any kind of risk of cavitation. Okay guys, so this was the simple calculation of NPSH required, which we discussed by the help of 2 examples, where in the first example the velocity head was not calculated, while in the second example we also calculated the velocity head and completed the calculation of NPSH available. Okay guys, so guys, that's all for this video. Hope you like this video and thank you for watching. And guys, for more video related to chemical engineering, process engineering, chemical safety, industrial safety, you can subscribe to this channel. And guys, as always, feel free to leave any questions and comment down below. Thanks for watching and see you in next video.